In the third column we write atomic mass, for which we need to know the atomic masses, otherwise it might be given in the question also, as in the present case the values of atomic masses are given. The next column onwards actual calculation begins. First three columns we get from the question itself, and as you know, atomic masses are expected to be known. Relative number of atoms. How do we calculate the relative number of atoms? If I take consider percentage composition as x and atomic mass as y, then take the ratio of x by y to find out the relative number of atoms. And then we have simplest ratio. Now to find out simplest ratio, what we do, out of these three values, whichever value is smallest, we divide all these numbers by the smallest value. Now here, if we don't get whole numbers, then we need the next column, that is simplest whole number ratio. As you can see here, one of the ratios have come to be 1.5, which is not a whole number. We cannot approximate it to 1, we cannot approximate it to 2 as well. Okay, so to multiply this 1.5 by 2 to make it a whole number. Now when I multiply by 2, we have to multiply by 2 for the rest of the ratios also. So now we get a whole number, that is 3. So the ratio of sodium is to sulfur is to oxygen. Sodium is to sulfur is to oxygen comes to be 2 is to 2 is to 3. So the empirical formula of the compound becomes Na2S2O3. That is how we should solve the numericals. Let's see another one. In the next question is given percentage of carbon, hydrogen and oxygen. So you can understand we are talking about a compound which has carbon, hydrogen and oxygen, and the vapor density of the substance is given, which is 45. Now your job is to calculate empirical formula as well as molecular formula of the compound. So here we have to make the table. We write the elements. First column carbon, hydrogen, oxygen. In the second column we write down the given percentages. In the third column we write down the atomic masses, and the fourth column we write down the relative number of atoms, which is percentage divided by atomic mass for each element. Now here what we notice, here out of the three values we got there is one number which is repeated, that is 2.22, and it happened to be the smallest number. So in the simplest ratio, what we have to do, all these three ratios to be divided by 2.22, and when we divide by 2.22, fortunately we don't get a fraction here anymore, we get whole numbers 1, 1 and 2. So I don't require the next column to make simplest whole number ratio. So carbon is to hydrogen is to oxygen is 1 is to 1 is to 2. So the empirical formula of the compound becomes CHO2. Now our job is to calculate the molecular formula as well. So first we calculate the empirical formula mass. So we use the formula of empirical formula, that is carbon is 12, there is one hydrogen, so 1, there are 2